Hello, everyone, and welcome to the Electrification Coalition's webinar focused on outside-the-box charging solutions. My name is Alyssa Linkle, and I will be leading you through today's Charging Infrastructure Series webinar, where we'll be looking at a broader focus, looking at all the unique charging solutions that are out there. While a lot of our content usually focuses on federal grant programs, building strong applications, and collaborating with key stakeholders in your city, this topic welcomes creativity in design, technology, and implementation. Whether you're a state or a local government with known design challenges, or you're just wanting to see what innovative solutions are currently on the market, this program is for you. We have speakers working in research and development, the private sector, and state agencies, allowing for all perspectives to be represented. We have a jam-packed agenda and anticipate a lot of great questions coming in, so feel free to send those through the Q&A feature, and I'll go ahead and introduce our first speaker. We have Don Linford, the Director of Innovation Ecosystems at the Aspire NSF Engineering Research Center, headquartered at Utah State University. In this role, he manages and nurtures Aspire's extensive network of relationships and activities with over 60 industry and innovation members. Don plays a crucial role in fostering collaboration, facilitating research project participation, and driving the commercialization of intellectual property across the center. We're excited to hear more about Aspire's work in EV charging. So with that, I'll pass things over to Don.
Thank you so much, Alyssa, and thank you, the Electrification Coalition, for allowing me to be here today. As Alyssa says, I'm part of the Aspire Engineering Research Center. It's funded by the National Science Foundation. We're made up of 10 universities. 9 of those are in the United States, 1 from the University of Auckland in New Zealand. And what is interesting about it is Utah State University is the host school or the headquarters of the Aspire Center. Utah State is located in northern Utah, and not too many people hear about. So there always the question is, why does Utah State have this expertise? And the reason is obviously our center director, Regan Zane, is a visionary in this space and has developed this program. Aspire is an acronym, so it does stand for Advancing Sustainable Powered Infrastructure through Roadway Electrification. As you can tell, I need to practice that more so it comes off more genuine, but that's what it is. Our vision, though, is we really want to impact society, and much of it aligns with the goals of the Electrification Coalition, positive impact on society through the reduction of greenhouse gases, increasing health and prosperity through that. So we are an engineering research center, so we take a little different approach in that people think, what is electrified transportation? For us, it's a bit more than just EVs. We do look across the system that we have. So intermodal transportation is something that is very important for us. So even though our calling card is somewhat called out here in the middle, where you can see this Kenworth truck with a in-roadway wireless power transfer unit underneath it, that is where people know us mainly for in the technologies we work on. But we do look across the system, and it's very interesting and it is complex. So we do look at aviation, but we really need to understand, how do we advance electrification through adoption, managing the grid, managing the technologies, and then sharing a lot of those costs and a lot of that integration. So currently today, the center, if you look at this picture, is really involved in many of the things that you can see here in the picture. We do have a current project with Stadler Trains in North America to create a battery train set for the US, the first in North America, where the Metra system in Chicago has already made orders for that. We work quite closely with transit authorities and a lot of their electrification of their buses and things like that. And again, the in-roadway. It's very important to think, though, how do we make this all come together so we're not creating silos and that we're really being efficient? So we know things are converging over time. As I said, we can't have silos. So our center really thinks that over time, we'll see higher autonomous vehicle, we'll have to share the grid, and things along that, and the workforce development that comes with it. Now, as I go through my presentation today, some slides I'm just going to fly by, and I think Alyssa is going to be able to produce or provide for you any of the PDFs that you'd like to see afterwards. But this just gives a sense of the size of us and the things we've done, and I'll just let you look at that. But we're fairly large, and we've been growing. So even though we're Aspire as an engineering research center with with National Science Foundation in at the end of its fourth year. This project has really been going since a long time, at least 10 years. And we've been growing quite rapidly. And I think a lot of our projects. So we've grown not only from a funding point of view, but the interactions that we have with the stakeholders in the areas of electrification, principally departments of transportation, other agencies like DOE, Federal Highways, and DOT. But we're now moving into a space where we're leaving the research center and we're going out into real world application. That's where a lot of our pilots and projects that we're dealing with is going on. Of course, in this space, when you talk about electrification of transportation, it does entail a lot of public-private partnerships. In the Aspire Center, we count on a lot of our industry members, and these are for-profit entities. And innovation are members which are not for-profit, and they're made up of agencies, as you can see, departments of transportation, but they're also part of municipal planning organizations, associations, some philanthropy, and such. Being a finance person and not an engineering person, I kind of look at this a very simple equation in the sense that on the left side, you have kind of the sellers, and on the right side, you have the buyers. So the individuals are trying to build the infrastructure or plan out for that, and then they need their partners who can come in, provide the technologies, the expertise, and the things that they need for it. And we're very happy with this industry and innovation board because it's quite diverse, covers a lot of different areas, and it includes both large and small companies. And as you can see, Michigan DOT, which Michelle will be speaking here soon, is also one of our members and part of our projects. One of our marquee things is we have the only North America facility related to electric vehicles and roadway. This is a roadway in which we're able to take technologies and test them before they go out into the pilot. So specifically for wireless power transfer, this is where our technology providers, including our own research and applications, are brought. They're tested here on the roadway. They are also tested against standards. In a couple of weeks, we'll have SAE here with some of our members using it as a test track. So it is a great facility. In the bottom right-hand corner, you can see we're expanding it. When it was built about 8 years ago, it met the needs, but today it's so much, the demands are so much greater. As you can see, all of the different applications that we're putting in there. So we've grown it by about 3 or 4 times. It will be inaugurated this year. This is one of the main things that if individuals are interested in testing technologies, and it doesn't have to be just electrification, we do have people who have sensor technologies and other things, we're able to provide that service. And that's just more of the EVR. Not going to spend a lot of time here, just take a quick photo and this will be available for you. But these are the 5 areas that we focus on. So we do go through transportation and data all the way to equity. And equity can be a politicized word in the world that we live in today. But for us, it's very important. We feel like that as we develop technologies, we need to make sure that society as a whole benefit for that. And we do know that there are communities that when you show up and say, hey, I have new technology, they say, oh, great, we're going to pay for it in some way, or they're left out. So it's also a question of making sure that these technologies are accessible, but also that we're training a workforce in the future that can handle and manage and grow that market and sustain this as well. It really boils down to 4 core projects. And this is the ones where we take research and we'd like to really put it out into the real world across these 4 projects. Electrified roadways, charging stations of the future, systems of systems, and learning and community engagement. Charging station of the future is we are looking at improving the technologies around that so it really becomes cheaper to use them and then put them into the roadways is the simplified way of talking about electrified roadways and where our pilots are. But our charging stations of the future, we are really focused as well on wired as well as wireless. We really want the technology to develop so it becomes ubiquitous and an ability for us to use it in the infrastructure. And then with that, obviously, we want to create tools that also help with adoption. So we do look at smart grid management, battery management, studying data as to where is the best place to put pilots, use cases, and things like that. And then learning engagement, again, is really focused around the workforce. But moving into kind of what really matters, what is wireless power transfer or dynamic wireless power transfer? This is a great slide. It's a bit technical, but in the end, you do need electricity to get to the roadway. You do need a transmitter, and you do need a receiver. So it's done through basically magnetics through wireless power transfer. And as if you can notice on the big truck, there are cases where you can put the receiver on either the chassis of the truck. There are technology providers who are looking to put them on the trailers as the receiver. What's important here to know is it's really an equation of power and distance. So if you have less distance for this power transfer to take place, then you probably need either more power or more frequency of these charging stations along the roadway as well. You'll also need to have power to the grid. Now, some of our pilots were looking at bringing the grid to the roadway and having that exchange there. Or we also have pilots that are looking at microgrids with solar arrays and other things like that. But in the end, it's very simple in the sense that you do need power. You need to get it from the roadway up to the vehicle. There is an air gap, so you do need to look at, well, what is the distance between the charger and the roadway, which is about 3 or 4 inches below, and then what is it to the receiver? So in the end, you need about 8 inches to 12 inches of what we call air gap at that distance to be efficient. And currently today, that efficiency between wireless and wired transfer is about the same. If you have about an 8-inch power or 8-inch air gap and you have enough power, then you're getting about 90 to 94% efficiency of the transfer of the power that takes place there. These are our pilots that are taking place. These are real world practices using wireless power transfer, and we do have it in Utah, Indiana, Michigan, as well as Florida. We do have 2 other states who have just recently, one state had put in an RFP. They're looking at a 10-mile section of roadway, and they'll also have a wireless power transfer demonstration is there as well. So some of this is dynamic wireless power transfer, which the car or the vehicle is moving down the roadway, and the rest is also static. So just to run through quick here is in Utah, we are rolling out a 1 megawatt charging static. So this is a Kenworth truck running UPS freight, about 200 miles round trip, both up north to Utah as well as to kind of south of Salt Lake City. It'll be running a double trailer. Utah's a great test bed because we have extreme weather. We have it very cold in the winter. We can get 8 or 10 degrees below zero, and we get very hot. In last month, we've had it up to 104 degrees. So it's a great way to test this, and it's a great test bed. Michigan DOT has a pilot in Michigan, and Michelle is actually going to talk about that, but it's the first actual commercial in-roadway pilot that's in place. We've also broken ground in Indiana. So on State Road 231, the Indiana DOT, as well as Purdue University, which is one of our core universities, is installing a wireless power transfer there. It's a little higher power, so this will go up to about 230 kilowatts as a power. So some of our solutions go from 30 to 50 all the way up to 1 megawatt. So power is changing over time as well. And this is just some of the construction that you can see that's there. And also we'll be using a Cummins truck on that pilot that'll be taking place in Indiana. And we also have Florida Expressway. We're looking at part of a freeway that's near Disney World. We'll also have NREX, one of our providers, will be doing that as well. So we have several pilots in play. So maybe skipping just because of time, and you've seen kind of our pilots allow the other speakers time. What I'd like to do is, and we've talked about the battery train set, is, if you have more questions, we'll have questions here, but you can also reach out to me because we're very content rich. We have so much stuff that we're doing. It's really hard in 15 minutes to give it. But I would probably I'd actually like to share a video that was made by Rocky Mountain Power, one of our members of Aspire Center. It really talks about, they call it the grid of the future, but some of what you'll be seeing in this video that they made in partnership with Aspire actually exists today, and some is in planning and other is futuristic. So if we could roll that video, that would be great. Thank you.
Control Center, so I need you to ramp up 150%.
090500. Have you open check open switch Julia 179 breaking parallel between circuit breaker 11 and circuit breaker 16 at Sand Creek.
Thank you so much. Again, I'll be able to answer some questions at the end, or feel free to reach out to me directly. Thank you, Alyssa, and thank you for participating today.
Great. Thank you so much, Don. That was a lot of really exciting wireless charging projects, and also so interesting that the SAE standards are set and tested at your facility. It really shows how research paves the way for transportation electrification in our cities in more ways than one. So great insight. Thank you. Up next, we have Greg Hall with ADS Tech Energy, which is an Electrification Coalition Business Council partner. Greg joined ADS Tech in August of 2022 and currently serves as Director of Channel Sales and Operations. He is a dynamic sales and business development leader with more than 20 years of commercial experience. Greg is passionate about ultra-fast battery buffered EV charging and pushing the U.S. market forward to embrace transportation electrification and a more sustainable carbon neutral future. We're excited to hear more about these solutions. So Greg, take it away.
Great. Thanks, Alyssa. I appreciate it. And thank you to the Electrification Coalition for giving us an opportunity to talk about how we can solve some of the challenges facing EV drivers today. Moving on to the next slide. Here's the agenda. We're going to talk about some challenges that face the grid today, our infrastructure challenges, and some economics behind that. We'll talk a little bit about how battery technology and stored energy can help alleviate some of those challenges, and then go through some use cases where we think that makes sense to addressing some of those challenges. And I'll just get through these placeholder slides. So here, let's talk about some of the infrastructure challenges that we see today here in the United States. And while the visual looks a bit dramatic, there's some truth behind it, because our electrical grid is truly challenged. The demands for growing power continue to escalate, but the pace at which we can build out and for the power demands that we need, it isn't keeping pace. And if we look forward to some of the clean energy goals that we have in the future, we're talking about thousands of megawatts of power that's going to be needed across geothermal, solar, hydro, and other forms of power would have to increase tremendously to meet these demands. And as much as triple it once we get into the 2050s. But complicating that a little bit is the existing infrastructure here in the United States. About 70% of the transmission lines that we have, according to the U.S. Department of Energy, are about 25 years old. And in a lifespan on transmission, or our transmission infrastructure lines in particular, is between 50 and 70 years. So we're starting to run up against challenges in not only how are we going to address the growing power demands that we have to serve the growing power needs in this country, but as well as the infrastructure itself. How is it going to keep pace? And all of this then becomes really important at a local level as we start looking at our local communities and how do we address some of these challenges in looking at just EVs. And EVs now are a growing part of all of our lives, and they themselves are putting additional pressure on the local grids for the demands that the EV cars are taking out of the electrical grid. Okay. Another challenge facing high-powered EV charging and doing that in an efficient way are the costs behind it. So related to the utility infrastructure and delivering the power than are the demand charges that are related to building out that power. So at the bottom, let me address that first. Demand charges are basically a fee that many utilities have to address the peak power demand that anybody needs at a given time. And there's a rate for that. And that charge is in addition to whatever energy utilization that you might have. And there's about 5,000 commercial customers across the nation, representing more than 25% of commercial customers here in the US, that are facing demand charges that could be as high as $15 a kilowatt or even higher. So when you look at that demand load profile and how EVs now are becoming faster and requiring higher power demands for charging, the economics then for addressing those charges become a little bit complicated. So just charging faster isn't necessarily an economic solution that people can deal with. So how are we going to address some of those challenges? Well, by leveraging stored energy in batteries, the charge box can alleviate some of those problems that we just talked about, both on the power demand side and as well as the demand charges. So ChargeBox, it is a brilliantly engineered system that helps alleviate those problems by operating off a low power grid feed using stored energy in the charge box here. There's 140 kilowatt hours of capacity. So taking a low energy feed from the utility, we can deliver a high power charging session that meets the demands of today's cars and cars of the future. And we'll talk a little bit about that in a few minutes. And that's the difference in the voltage architecture of cars. So ChargeBox is an optimized system that's going to deliver fast charging to cars when and where they want it, provide high availability uptime. We don't need new transformers, and we don't need to tax the grid. So people that want to install these systems it's not plug and play, but you can essentially drop this in anywhere there's 200 amps available in a commercial system. With 480 phase in the panel, you're good to go. And most commercial businesses in the country have 483 phase service and 200 amps available in the panel, allowing them to take advantage of the ChargeBox system to provide fast charging that doesn't stress the grid. So how do we do that? Well, if we take a picture here, the way that looks from the grid is from the transmission lines and distribution, you can have as little as a 50 kilowatt grid feed up to 100 kilowatt grid feed feeding ChargeBox. And from there, you can output 320 kilowatts to a car. And that's happening because of the stored energy in the battery booster system in the ChargeBox. There's some other advantages to the system as well. You can see down here the distances involved creates flexibility. So depending on site requirements in any environment, you don't necessarily have to have the charging system right near the utility feed, and you don't necessarily need to have the charging dispensers right next to the charge box. So another feature and design of the system is the flexibility in accommodating different site characteristics from what different needs that a site might have. Now, this slide talks about how charging actually happens. It looks a little bit technical, but I'll walk you through it, and it's not that hard. This blue bar down here in the blue system is all the charging. The dark blue system is 100 kilowatts of power coming from the utility. The light blue feed is the supplemental energy that's coming from the batteries itself and ChargeBox, which is represented down here in the green. This is the stored energy. They work together in a charging session. And what we're seeing here is just one charging session for 25 minutes that delivered a lot of energy in a short period of time. So that's almost 70 kilowatt hours of energy. And it had a very high peak draw, almost 270 kilowatts. So that's where I want to talk about the cars of today and the cars of the future. A lot of the cars today are built around 400 volt architectures. And so what that means is these EVs are charging around 150, 170 kilowatts. But some cars today, and there's half a dozen cars that we could talk about that can charge very, very fast. Those are built on 800, 900 volt architectures. And those cars need support to charge at those rates. And that's important when it comes to the customer experience about charging and how fast that they can charge. Getting into some of our use case examples of where all of this makes sense. First, we'll talk about public charging locations, let's say convenience stores. This is an example in Stuttgart, Germany, near our headquarters. And this is an environment where you're going to have a lot of traffic, a lot of EV cars coming through. So when you have a lot of cars, they need to charge quickly. People can't just queue up and stand in line. They're going to move on. And so ChargeBox is optimized and designed to be able to deliver very fast charging sessions because we can output a lot of power very quickly. And we can do that in an efficient manner without stressing the grid. So again, we're not stressing the grid. We have a low power grid feed coming into the system, and we're using the battery technology and the stored energy to deliver very high power to a car if it requests it. And then we can do that very quickly so that the next car can come in and we can move cars through that cycle very, very quickly. Another example of this, and again, we're talking about how that works in the background and why it works. This is a day's worth of charging at that location that we were just talking about. 24 sessions in a day, and we delivered almost a megawatt worth of power. That's how much energy was delivered and passed through ChargeBox and into the cars. But we didn't take a megawatt of energy from the grid. ChargeBox and its stored energy helped deliver and offset the energy requirements from the grid to deliver to the vehicles that wanted to be charged. So what you see here in the blue bar are the charging sessions. That's the activity that was charging to the cars. And you'll see the corresponding need or request from the batteries. The stored energy is kind of a mirror image of what the cars are requesting. And you see here, these two sides represent the complete system. So ChargeBox has two dispensers, and there's two battery strings in the box. So in this case, we may have one car attached and charging, receiving the full 140 kilowatt hours of battery storage, or you could have one car attached to dispenser 1, another car attached to dispenser 2, both charging simultaneously up to a maximum of 160 kilowatts, or combined 320. Okay, and this is just another time frame looking at a week session where we passed 4.8 megawatts of energy, 132 charging sessions with an average delivery of about 36 kilowatt hours per session. And with a max draw of 267. So you see these blue spikes here. These are going to be EVs, and these would be cars built around 900 volt architectures. And those are the cars that are coming. Some exist today. More of those cars will exist in the future because those type of vehicles can charge twice as fast as most of the cars today built around 400 volt architectures. And they can do it more efficiently, right? Because they draw less current and it produces less heat on the battery. So it's just a way to say ChargeBox is a system that can not only serve the cars today, but it's also engineered and designed to serve the cars of the future and address both in an optimized fashion for charging. Another use case that we see that needs to address both the demands, the infrastructure limitation of the grid, right? So that we don't have to, you can use low power grid and you don't have to put a lot of expensive equipment to upgrade the service from the utility, as well as being able to address a lot of cars in a charging session and keep the economics under control so that you're not getting pinched with a lot of high demand charges, are automobile dealerships. And we have a very strategic partnership with Porsche. That's why it's featured here. But Porsche was interested in exactly this kind of system where they could help manage the economics of high-powered charging at a lower cost and deliver high-powered charging sessions, in particular to their car, the Porsche Taycan. And ChargeBox was a smart solution to address all of those needs of high-powered charging at a lower cost of operation and being able to do this again and again and again, service a lot of cars. A bigger application, and maybe something I see here in the US to address in what we see here, high density residential living. It could be commercial operations, business parks, high-rise offices, anywhere there's going to be densely populated people and lots of cars. This is another smart solution to avoid the need to try building out with a lot of level 2 chargers, which can become costly and expensive, but doesn't address or meet the need where the cars are today, and certainly won't scale into the future. You can't build your way out with level 2s to serve the growing demand of vehicles that are coming off the lines. This year alone, I think we'll see probably 1.2 million EVs, about 7% of auto sales, growing over the next 4 years to almost 3 million EVs sold and about 17% of all EV vehicles. So EV vehicle sales and the demand for EVs and the demand for having an efficient way to deal and serve EVs is just going to grow. And being able to do that in an economical way without stressing the grid and putting in expensive upgrades means that businesses and communities can start thinking about how can we take advantage, or how do we use today's limitations in the power grid or in my given operational environment and still deliver high powered charging in a more efficient manner at a lower cost. And ChargeBox is a great way to do that. So in summary, you can look at ChargeBox across kind of 3 dimensions, either dedicated charging, where you're putting in very specific level 2 chargers for parking spots, or a shared environment. In either case, there are limitations on how you can scale that solution. There's limitations to the amount of time a car can stay in a particular spot to actually get a full charge. And then if you want to look at level 3 direct-to-grid charging, which is an alternative. But as I was saying, direct-to-grid chargers can charge very, very quickly and serve cars fast, but it's more expensive to put that in. It requires potential upgrades from the utility and their potential demand charge implications for doing that. But battery buffering is a smart combination that optimizes all of these challenges, grid limitations, demand charges, and being able to serve customers relatively quickly. So I'll conclude with this last slide, saying that even though that we do have some charging challenges with our infrastructure, with the economics that are behind it, battery buffering and leveraging stored energy is a smart way to do high-powered charging without the need for grid expansion. It can be more economical to do that in the long run. and you can deliver a better customer experience overall. So please consider it. Thank you very much for everybody's time. And I'll turn it back over to you, Alyssa.
Great. Thanks so much, Greg. This is a great solution, and I can definitely see how the battery buffer charging can benefit those who have to plug in during those high peak times, like multifamily homes and workplaces, as you mentioned. Also, these groups have been a major focus area for a lot of federal funding projects, so it's great to see innovation that's focused on those groups. And speaking of federal funding, we actually wanted to dive further into what these projects look like from the state and local government side, as a lot of our audience is coming from state and local government. So to do so, we have Michelle Mueller, who began her career with the Michigan Department of Transportation in 1995. Michelle serves as a senior project manager in connected and automated service vehicles. She has more than 11 years leading numerous intelligent transportation system projects in the MDOT metro region area. She led the overhaul of the regional communications network and the current ITS infrastructure. She also oversaw the construction and integration of the new Southeast Michigan Transportation Operations Center, also known as SEMTOC. Since a lot of our audience is joining from the state and local governments, we knew Michelle's insight would be vital to help you implement what you've learned today. So with that, I'll hand it over to Michelle to tell you more.
Great. Thank you very much, Alyssa. And thank you very much to the coalition for having me participate today. So I am here from, as my background says, pure Michigan. So I'm happy to bring Michigan to the forefront and share the opportunity that we've had here to have a first of its kind, the first actually inductive charging, wireless road charging project, as some term it, on the public infrastructure. So if you could start the slides, please. So with that, again, super excited to share this opportunity. Always happy, obviously we'll have questions here, but always happy to take questions at any point in time as well. So we did have our first of its kind road here, as I mentioned. As you can see here in the picture is actually our e-transit vehicle that is part of the project. So maybe stepping back a little bit before we get into the super exciting part of the construction and the visuals of that, is just to share a little bit of history to the project. Many of you probably did hear a little bit ago, our governor announced that we would have the first electric charging public road in the US. And we are very happy to say that we launched the first segment of that at the end of 2023. So as we start to look into how the project came about in the different pieces, it takes a collaboration, right? And most of you are aware of that, but really to bring home two sets of collaboration areas. One is on the public sector side. So as you look at those boxes, those are all government agencies. A lot of those, with the exception of the city of Detroit, are all state of Michigan agencies. Michigan is very unique in the fact that we actually bring all of our state agencies together, and we actually create a unified network, but unified opportunity for companies that do come and invest and work in Michigan. And then in this particular project, as with others, we were super excited to have the city of Detroit be a part of that as well. On the other side of the circle, and as you start to look at those merging, is we have our company partners. So our contract is with a company called Electrion, and they have a couple actual subcontractors that are part of the project, with it, which you can see on here is Jacobs and Next Energy. And then we do have those that are committed partners that bring different aspects to the project that aren't actually considered a subcontractor. So what are a couple of the things, just to hit on the key areas that we looked at as part of this project and going into it, was really looking at the opportunity to say, what are our use cases? Why are we doing this? And what are we trying to target? So you can see from this picture, a couple of those are different things. We have things we look at for a shuttle service, moving people locally, maybe between buildings, parking garages, to downtown, different areas. But then looking at, you can last mile delivery, you look at your Amazons, your FedEx, your UPS, all of those folks that, pull up, drop off. If they're an electric vehicle in this case, we want to have an area where they could charge while they're doing those deliveries. and then also have the ability to have the inductive charging in the roadway that they traverse over. So not only are they getting it in motion charging, but we also have the inductive charging that is in a stationary point as well. The other key pieces that was a major one being transit. So enabling the opportunity to have transit. They are a defined route in most cases. So they do a circular shuttle, or movement, I should say, of dropping off and picking people up. So how can we enable the opportunity through this project to give them a charge as they traverse over the roadway, expend potentially that energy or some of that energy and regain that back when they come across the inductive charging roadway segment in their route. The last two that are on here, one is freight. We do have a freight aspect to it. We do get quite a bit of freight on one of the particular locations that you'll see in a minute. And then the last being passenger vehicles. Passenger vehicles, believe it or not, everybody kind of thinks they should be they're at the top. They're actually at the bottom of the use case for us. Passenger vehicles are very difficult to do a pilot with. People, are very concerned about things being mounted on their vehicle, about their personal protection and awareness and things like that. So we really did not target them. I will say, though, the piece of passenger vehicles that is a part of the project is working with our industry partners here in Michigan. We have a huge foundation of automotive providers, suppliers, and whatnot, and we continue to work with them to provide this pilot to enable them to be testing with their vehicles and understanding based on different sizes, different types, different speeds, those types of things as to what kind of charge they can actually get on the different types of vehicles. So for those maybe not so familiar with Michigan, this is down in the city of Detroit. You've probably recently seen hot off the press with the opening of an entity called Michigan Central, and that has a testing lab portion of it called New Lab. So the first piece that we did, the quarter mile on 14th Street, is actually the piece that we launched at the end of 2023. So we are currently operational on that. We're currently doing testing, starting to gather data and understand, how much are we getting off of the grid? Obviously the roadway does connect to the grid. How much are we losing? How much loss is there between that grid transfer to our management units? And then how much loss and how much actually transmits into the vehicle and into the battery itself. The other piece that we're testing is based on speed. So as you start to look at how fast the vehicle is going, does it impact how much charge it's receiving as it transfers between the coils? And then, the other elements that, maybe we don't think about quite as much is, really what are the lessons learned out of this? We had actually a segment of the pavement that failed. It had nothing to do, to be clear, with the inductive charging network. But what it did is it gave us an opportunity we weren't expecting, is to understand how do we do maintenance on these types of roadways, knowing that we have a coil bed underneath it. The other piece you see to the on the side there, the 3/4 mile, we are currently underway with instituting a design to put in with a road reconstruction project. So now we even have the opportunity with this pilot here in Michigan to say the first 1/4 mile we did was a mill and resurface type treatment to the road, where we added the inductive charging. The next 3/4 mile that we're working on is looking at a total reconstruct. What are the differences to those installations? How do those affect the road? What are the different processes that we may have to use both on the design side, but also mainly on the construction side and staging and those types of things for those activities? On the other side of the picture here, you can see our static triangle area, which I referenced, where our last mile delivery, transit, shuttle, those folks can actually pull up and be on a stationary inductive charging location while they're making their delivery, while they're picking up passengers, those types of things. So again, another opportunity for us to engage in data collection to understand all the attributes associated to that type of charging as well. So now we can start to get into what I consider the super exciting part, which is some of the pictures to actually see. It's very hard for people to imagine what this is that we're talking about. So happy to be in a situation now where we can actually show some pictures. This picture that you see here is actually over in the charging area for the static location. And you can see we do some testing So not only do we do the installation, but before we cover it over and continue the process, we're constantly testing to make sure that we've achieved, we have connections, we have all these things before we cover it over. And the top picture, you can see what we call a ground management unit. For those in the industry, very much similar to what a large signal cabinet that you may see on a ground mount location at an intersection. And then the next two pictures are, which I have some bigger pictures, so you don't have to try to squint to those. So this is actual construction. We actually started the construction based on just some logistics and timing. We ended up against weather. No surprise here in Michigan. We deal with it all the time. This was no exception. So we ended up, we had a huge snowstorm coming in actually to surprise us. And so we started at about 4 a.m. under lights with the installation and completed it just before midnight. So what you're seeing here in these pictures is actually the trench that was put in. So the road was milled off. We actually put a trench in, and you can see the coils that almost look like 8s for the most part, 2 squares connected together. And then those interlock to each other. They only interlock to keep them in place. They're not actually connected that way. What connects them is you maybe can see a little rectangular piece that's in that trench. That's actually the mechanism where the electrical cords and stuff all run through that trench and all go back to the management unit for operations. So this trench actually gets filled. You can see them coming along with the concrete. It's not actual concrete itself. It's more of a slurry mix for those maybe familiar with that. But it's just a lighter weight mix that this trench gets filled with prior to it being covered over with, in this case, asphalt. So you can see this is what those coils individually look like. We did have an unveiling in November of the project, and we did keep a section open, which is what you're looking at here for media. We had a large amount of media come out, far more than we expected. We actually ended up having members of the community come out and actually be part of the unveiling. And on the right side of the picture, we actually had a ceremony associated to it, and that is our director signing the coils. And that coil with the governor's signature and all of ours is actually housed at Michigan Central today. So what are some other aspects to this? So it's easy to get wrapped up in the technology. It's easy to get wrapped up in the data and the testing and all of that. But there's other key things that we're embarking upon as part of this pilot. And I want to just touch on a couple of those because as people, that are participating in the webinar and that we interact with and talk to that are looking to do this in their states, in things is these are things that you really need to be thinking about in addition to the, the engineering and the technology side, as I said. One of those is you can see these are all real pictures to this job. These are different conferences, different public engagement meetings that we held. We actually took the receiver and we actually took the coil to those meetings, and people were embracing the fact of being able to touch and feel those, to understand what is this under the road. But it also gave the opportunity for a lot of discussion around, can it hurt me? Can it hurt my family? Can my kids ride their bike? Can I walk my dog? All of these things that probably us in a technical engineering side take for granted, that we know the answer to this. These are the things that the people that were putting this in their neighborhoods and were putting this in their environments that they use are really curious about and interested in wondering. So we took a very large effort of that outreach, of the engagement of those activities. The bottom picture there in the center was another activity that we did where we opened it up, not only this project, but others, but we opened that up to the community to come out and actually see what's happening there, understand, see pictures, ask questions, those types of things. So the other a couple pieces really are, jobs and workforce. So we've done quite a bit around opportunities for training, opportunities for awareness and engagement. The companies that you saw doing that work have never done this before. So we had an asphalt company come in, to do the paving work. They didn't know what to expect. You can prepare and you can have meetings and discussions as much as feasibly possible. But until you're actually on site in there, it's a very difficult thing to understand. So as we were paving, we were taking precautions to ensure that the paver and the skid did not lift up the coils, right? Something that maybe you don't think about till it happens, but we took some precautionary measures to make sure that that didn't happen. Also, when we did our final rolling and compaction and things, we did not vibrate in the first lift, but we did vibrate in the second. So there's the coils are about 4 inches down on the underneath the pavement surface. So we have so as we continue to look, and there's other things in this, as Don mentioned, we're happy to be working with Aspire. We look forward to continuing that relationship as we collect our data now that we've been able to move into that piece. We will continue through the next installation, which will be on Michigan Avenue for the reconstruct portion, and then we'll be collecting data on that. We already have a wide, vast interest and partners, which will be announced shortly, in these spaces of last mile delivery, of transit, of shuttle. We actually have a project that was being launched. It's recently been launched in Detroit that we're now looking to make so that they can actually use this inductive charging environment. So with that, my contact information is on the screen. Feel free to, if possible, you can scan the barcode there. That does take you to our website. So there is an MDOT website associated to the project with different media interviews, different Q&A type things where you can gain a lot of information from that and other projects that we have going here in Michigan. So again, thank you very much for the opportunity to share this great project that's happening here in Michigan with all of you. And we are excited to take the opportunity for anybody interested to reach out. But then also, if you're in Michigan, feel free to reach out to me, and we'd love to show you what's happening here. So thank you very much, Alyssa.
Thank you so much, Michelle. That was really great to see how when these projects are getting implemented, it's an opportunity for community engagement. It's an opportunity for those folks to ask those questions they may have been hesitant to ask. So thank you for flagging that. With our limited time left, we're going to jump into Q&A. We've got some great questions coming in. So any that we don't get to, we will do our best to include in a Q&A with the recording of the webinar and get those answers from our speakers. Jumping right in, the first question that we had was for Dawn. With wireless charging, are these vehicles equipped from the OEM with wireless charging capabilities, or is it an aftermarket add-on?
The first Kenworth truck used at our EVR is a retrofit, so it is aftermarket. The one for the static charging, the one for the Indiana Pilot and others will be OEM trucks that we will be using. So they are done by our OEM. Only the first truck used at our EVR was a retrofit.
Got it. Thank you so much for that. That's super helpful to know. The next question came in for Greg. So how does the cost of ChargeBox compare to utility upgrades? So say for someone trying to build a NEVI compliant charging station with 4 150 kilowatt ports.
Yeah, what a great question. Thank you for that. And not to be coy, but it really depends. We'd have to look at things like your demand charges. We'd want to take a look at that and see how that would impact the costing model. We'd want to look at utilization rates and what kind of traffic and charging and type of charging do we think that you'd have. So there are several factors and variables involved in looking at that. I wish it was just a one-dimensional, could give you a quick answer, but it's a little more involved in that, and I'd be happy to address it.
Sounds great. And we'll be sure to share contact information of all of our speakers. So if you have more specific questions, you'll be able to reach them as well. Going back to Dawn, we had a question for these wireless power transfer pilots. Do vehicles maintain highway speeds, or could you imagine a lane where trucks could slow down maybe to 35 to 40 miles per hour in order to spend more time on the segment that's providing the power, sort of a compromise between stopping to plug in and keeping freight moving?
Yeah, this is a frequent question because people imagine that you'd have to slow down and get a charge. The reality, it's kind of, you don't have to slow down, but the function is how long is the how far is the charging station? Is it a quarter of a mile? Is it a mile section? Will it be shorter? And then if that's the case, then you'd have to be more frequent. But reality, if you were to maintain highway speeds, you'd probably have to have more frequent charging, in-road charging stations along the way where you just be go over on the top of them. But right now, we don't plan on creating lanes for the vehicles to slow down. They would maintain whatever highway speed or what's there. And then we would configure the charging based on kind of distance and power, like I talked about, is to see how we could transfer it.
Great, thank you so much. That's exciting to see how charging speeds will just get faster and we'll just keep on moving. Exciting to look towards the future. We have time for a few more questions. So this next one also came in for Dawn. What's the realistic viability of the Purdue project on a bigger scale, given the cost and infrastructure upgrades needed? I'm curious of the benefits versus plugging in physically. First thing that comes to mind is if the driver can stay in the truck.
Let me go reverse order to that, because the reality is when we get to scale, the benefits are tremendous. Is when you get to the scale, you'll actually have reduced sizes of batteries, which entails a lot of opportunity in terms of heavy transportation and be able to haul more goods for less and things like that. Also the benefit, like you said, especially if you're thinking about depots and such, drivers won't have to get out of the truck to plug things in. So if you're doing drayage and other things, you think about it, be more efficient. What you're pointing out in the first part of your question is viability. Today it's not viable, and that's why the pilots exist to gather this information. Our two largest barriers, there's several, right? But the two largest that we're working on is the infrastructure as well as the battery size. So we really need to understand the integration of that and how we can create a better infrastructure to reduce the battery size, understand the cost of building that out. We do have a costing model so that we're looking at, or if you want to build a roadway, and happy to discuss that with anyone afterwards if they want to reach out to me, and we can kind of work with you on what we would put into that. But basically the idea is to get to scale, cost about the same as it does today to install in the roadway, except for the incremental cost of electronics. But the benefits are tremendous from there.
Great, thank you so much for that. That was a multi-part question, so I appreciate you being concise with it. We are at time, but we have a couple of other questions that we will be sure to circulate with other resources as we get those answers to you. I'd like to thank our speakers so much for their insight, and to you all for attending. We hope this session was informative and inspiring for what's to come in the future. We invite you to stick around for our post-show slides, which will show more events and programs coming from the EC, including our Charging Infrastructure Week coming up in October. And thank you guys so much. We'll see you next time.